developers, we actually spend more time reading code than we do writing code. For example, we need to read code if we are adding new features because we need to figure out where to add the feature and how it currently works. We need to read code when we're fixing bugs because we need to figure out what's wrong and where to fix it. We need to read code if we're trying to understand a new system because we joined a new team or want to contribute to a project that is new to us. We need to read code during code reviews, when we're learning new technologies, and all kinds of tasks that we do in our daily jobs involve reading code. A quote from The Programmer's Brain by Feline Hermans says that developers on average spend as much as 58% of their time comprehending existing source code. Feline Hermans is a professor of computer science education at the Vrije Universiteit in Amsterdam. And she wrote this book based on courses that she gives about the programmer's brain and everything that we need to know about cognition. And I find it an extremely useful book, and I will be quoting from the book during my talk. So we spend more time reading code than writing code, but we don't practice reading code explicitly, or not a lot anyway. And like I said, Feline is a professor of computer science education, so her research domain is literally teaching programming, and she does a lot of work in that area. She also speaks at conferences. And she spoke at Strange Loop in 2019 with a talk called How to Teach Programming. And in this talk, she discusses research from 1992, which is before I even learned programming. And in this research, they are teaching a group of students computer science and programming concepts. And the experiment was they split the group in they split the class into three groups. The first group was learning by writing code and reading code. The second group was writing code and reading code, but with explanations of how the code came to be, what decisions were made and why. And the third group was only reading code with the explanations. And they found that actually the second and third group were better able to reproduce the programming concepts than the first group that was not reading the explanations, but only writing and reading code. And this is actually contrary to how we learn programming, because we all learn programming by writing lots of code, right? So maybe we should change that a little bit. After the talk, someone came up to Feline and said, so what if we did practice reading code explicitly? And that's how Code Reading Club was born. They created a code reading club specifically for deliberately practicing reading code. And you can go to the Code Reading Club website if you want to read more about it. They also have virtual events that you can join. I checked this morning, there aren't any planned currently, but keep tabs on their website if you'd like to join a Code Reading Club, because I heard about Code Reading Club and I thought, that sounds amazing, I want to do that. And well, sometimes the universe and the stars align, because a friend of mine actually reached out and said, hey, we're starting a Code Reading Club, do you want to join? I'm like, yeah, I do. And I did. So let me tell you a little bit about Code Reading Club. What we do is we print on a piece of paper, print a piece of code. Finding a piece of code that fits on one piece of paper and still has some significance is quite the challenge, I can tell you. We take turns in the club facilitating the sessions. We have people in the club who do work in different industries, in different countries, in different programming languages. So we get a nice sampling of different kinds of code. We print the code and then we do structured exercises to try to make sense of the code. And let me give you some examples of the types of exercises that we do. We usually start with an exercise that's called first glance. That's literally what it is. We take 1 minute to look at the code, and the exercise is write down the first thing that you notice about this code and why that is something that you notice. And what's interesting there is that some people notice, oh, I find something familiar. Here's a word that I know, or a domain term that I know, or a programming syntax that I know. Other people find stuff, hey, this is new to me. I've never seen this syntax before. I have no idea what this word means. And there are always people who are immediately trying to find out what language it is. So, which I find is very interesting. The next exercise can be to identify components in the code. So variables that are declared and where are they used throughout the code. Methods that are defined and where are they called. And to basically draw how they are used throughout the code. The next exercise we do is to identify the most important lines, which is also interesting because if you don't define what important means, people use different interpretations. So you get different lists of these are the most important lines. Some people might identify as the most important the lines that tell me what this code is about. So that might include a comment or the name of the class, if it's a good name that covers what the code does. Other people might identify the lines that define the flow through the code. So if I take these 5 lines, then I have the control flow throughout the code. We have a few testers in our group, so they will identify, oh, these are the lines where something happens and I need a bunch of test cases. Those are the most important for me. Which just shows that there can be different perspectives, which is very interesting to me. We like to identify concepts in the code, because if there are unfamiliar concepts, that will keep you from truly understanding what the code does. And finally, we will take a few minutes to summarize to our best understanding of what the code does. And what's interesting to me is that even though the previous exercises don't explicitly look at what does the code do, somehow by working with the code and doing exercises about the code, much like comprehensive reading, we end up with some idea of the meaning of the code and what it does. So I really love doing these code reading clubs. I've been doing them for about a year, I think. We try to do a monthly session, but we can't always because sometimes people travel or are on holiday or are off. But what I love about Code Reading Club is not just learning how to read code and exercises to approach reading an unfamiliar piece of code, but also I really love getting other people's perspectives and noticing that something that is very obvious for me with my particular set of expertise or experience is not obvious to someone else coming from a completely different language or a completely different domain. And also noticing my own assumptions. Oh, this is clear, nobody will wonder about this. And then someone's like, so what does that mean? And I really love that we, in our diverse group of people, there will usually be someone who can answer someone else's question. Like, I really don't know what's going on. Oh, I know, I'm familiar with this language. So we can all learn from each other, and I really, really love that. That's why I go to conferences, right? And another important thing is the mindset of understanding or reading code, not to judge it, which is what we usually do when we're reading code, because we are doing a code review and we're trying to find fault with it. But really to suspend that judgment and to first read the code to understand it before we make a judgment, because there can be any number of reasons why the code is the way it is. Because nobody sets out to write, anyone sets out to write bad code? No. Okay, maybe. My friend from the Netherlands. And that ties in with what Venkat was saying this morning, right? First understand the problem before you try to solve it. So first understand the code before you try to add to it or fix the bug or whatever. So in Felina's book, she mentions several reasons why code can be confusing. She mentions a lack of knowledge, a lack of information, or a lack of processing power in the brain. Excuse me. These are tied to our cognitive processes, which she also talks about in the book. So we have our long-term memory, so things that we've stored, things that we've learned, things that we know. We have our short-term memory, which is the information that we can memorize in the moment, that we can store for a little bit of time. And then we have the working memory, where we are working with this information. So code can be confusing due to a lack of knowledge, and this lack of knowledge can be either in the programming domain, it can be a language or syntax you're not familiar with, or programming constructs or algorithms that you don't know, or it can be in the business domain. So it can be business concepts that you don't know, domain concepts, business logic that you're not familiar with. And we can deal with this in several ways, the way that Feline recommends is to create a list of the things that you don't know and to research those. And for the ones that are necessary for you to know off the top of your head, to spend some time actually memorizing them rather than looking them up all the time. Of course, that's only for the stuff that you will need to have at the top of your head. And she also recommends creating this list so that you have a plan to work off of, so that you don't end up going down all the rabbit holes, researching all of this stuff and getting distracted, but you actually have some sense of progress. Oh, here's the list of things that I didn't know. I've researched those now, I can continue. The next one is lack of information, and that can be anything from unknown details, unfamiliar names, code that is connected in unknown ways, just too many things going on at once. So think also about cyclomatic complexity, for example. And this is related to your short-term memory. Has anybody ever heard that you can store 7 plus or minus 2 things in your short-term memory? Yeah, I'm a back-end developer, that's what this slide means, but I can't design my way out of a paper bag, sorry. So it turns out that it's actually less than 7 plus or minus 2 things. You can keep about 2 to 6 things in your short-term memory, so that's not a lot. And Feline suggests dealing with that by way of chunking. So rather than looking at all of the individual details which might take up individual slots in your short-term memory, look for patterns. So if you're familiar with the model view controller pattern, for example, oh, this application uses a model view controller pattern, that is one slot. Otherwise, I need to remember, oh, there's a model, there's a view, there's a controller. So, try to find patterns in the code. The last one was lack of processing power in the brain. If there are too many processing steps, too many variables to keep track of what's happening to them. And ways to deal with that is actually by using memory aids. Not trying to keep all of the information in your brain, but actually offloading it to a piece of paper. For example, a dependency graph or a state table. So a dependency graph might look like this. This is a screenshot from Code Reading Club, which is related to some of the exercises we discussed. So identifying the components in the code and seeing where they are used throughout the code gives you an idea of the flow of the code. And circled are the lines that someone thinks are important. A state table can help you if variables change a lot over time. Using a very simple nested loop as an example, you can for sure come up with more complicated examples from your own code base. But using a state table to see how the variable changes over time can help you. Feline was writing another book called Code Reading in Practice, but unfortunately she scrapped it due to having too many great ideas to work on. So hopefully she'll come up with other amazing stuff. Anyway, I was able to read it on O'Reilly in the early release, and in this book she discusses several dimensions of code reading: structure, domain, concepts, and context. So in terms of structure, code is not read linearly. We don't read it like a book from start to finish. It doesn't run from start to finish either. It might call different places in your code. So we can look at the structure of the code to help us get a mental map and understand what's going on. In terms of domain, we can look at the behavior of the code, what does it do, and the data that it deals with. We can look at the concepts. Again, these are programming concepts or domain concepts. And we can look at the context, because an application is used by users, is part of an organization, is part of a landscape and might call other applications. And there might be reasons why this application was built in the first place. And that can also help, like having a bit of that context and history can help us understand the code. So what does that mean when we're reading code in practice? We'll look at some use cases. One being that you have to understand a new code base because you're joining a new team or a new organization, or you need to contribute to a code base from another team or an open source library you might want to contribute to. So you have to figure out, what does this code do? In order to figure that out, like I said, we need a bit of context. So if you are onboarding to a new team or someone is joining your team, it can help to explain, this is the application that we're responsible for, or the part of the application. This is why it was built. These are the people that we serve. These are the teams that we work with, or the other applications that either we call or they call us. A lot of things that you can't find in the code base directly, but that is relevant to work on the code base. And then when we want to start figuring out the code, we might start by checking out the code. Because if you read your code in the IDE, then your IDE has a lot of features that can help you make sense of the code. So let's take a look at how we might familiarize ourselves with a project. So we checked out the project. I deliberately picked a smallish example to start with. So I'm using the Spring Pet Clinic. For those who are not familiar, it's a demo project by the Spring team. Some people are familiar. So some of the first things we might do is we might look at the project view to find out what packages are in this code, and just look at the packages and the classes. Again, this is fairly small, so we can quickly take a look. And we see that we have some business domain concepts in the names of the classes and some programming concepts in the names of the classes. Next, if we have to work on this project, we might want to make sure that we can actually build the project. Highly recommend always doing that. My preferred way is if I'm using Maven Clean Verify. So that would be the way that I try to build the project. If that doesn't work, I might go look at the README to see what the README says about building the project, etc. Since this is a demo project, they've been very extensive in different ways to run this project. Hopefully there's a lot of useful information in the README on how to build the project, how to run it locally, how to run the tests. We have built success, so now I know that I'm safe to make changes to this project if I want to, and I know that at least I had a working version. So if it breaks, I know that my changes broke it. I really like having a README that has relevant information, because I have worked on teams where it was more like this. One of the teams I was on at my last job, we had several microservices, and they were all built in different ways. This was about 8 years ago. So some were running on Tomcat, some were running on Jetty, some might have been running on Spring Boot already. But each one was different. So I had to remember basically how to run all of them. This was literally, or quite literally, one of the READMEs I ran into. So one of the first contributions I did to the team was to add READMEs to all of the project. Okay, this one runs on, and here's how. You might also find out that you need to install additional stuff to be able to run the projects and whatever. Next, we might want to actually run the application to observe how it works. So we can see what the software does. It will be helpful to know how to run it locally also if you want to test your changes that you might be doing. So all of these are relevant if you're going to be actually working on the project. Let me find a browser. Come on, Mac, work with me. There you are. Also, pet tags.
puppies and kittens, yay. So now we can observe what the Spring Pet Clinic does. We can see what kind of endpoints there are. We can find owners. We can find veterinarians. They even built in an error message, so you can see how an error might work in the application. Where did my... There you are. No. We might want to look at what the error does. So if you're using an AI assistant, you might be able to ask for explanation on the error. Or if you've been doing software development for a while, you know how to Google error messages. Yeah. But now we can ask right in our IDE. Isn't that cool? So lots of ways that our IDE can help us figure out how to get started with a project. But what if we are looking at a more complex or larger project? So I'll take the other end of the spectrum of projects I've worked on, which is the Cucumber JVM, which is a library. Anyone familiar with Cucumber JVM? Okay, for those who are not, Cucumber JVM is a behavior-driven development tool that you can use if you want to use behavior-driven development for developing your applications. So this is the Java implementation of Cucumber. It's also available in other programming languages. And it needs to be able to work with different testing tools on different platforms, etc. So as you can see, we have a lot of packages related to this project. So right away, we might see some names in the names of the packages that are unfamiliar. Excuse me. So we might add those to our list of things to research if we want to totally understand this project. But we might also feel like, I don't even know where to start. Which of these packages would I look at first? Core is a hint that might be a central package to the application. So that might be a place to start. But even there are a lot of packages included in that, so I might want to get more of a high-level overview of how everything is related. So one way to do that is to generate diagrams. Of course, if I'm auto-generating diagrams for something, yes, I saw that face, like, that's a lot of classes. I can't even read that, so a class diagram might be one way of looking at the code. Fortunately, we can search for stuff in the generated diagram and look at only parts of the diagram. Another useful diagram might be the project modules, which tells you, okay, Cucumber Core uses these other modules, and if we look at the individual packages one by one, we can draw our own bigger diagram of how they are all related. I also highly recommend drawing your own diagrams over just using the automatically generated diagrams, not just because you can draw the diagram for only the things that you're interested in, instead of having auto-generated everything, but also because if you're drawing your own diagrams, you're actively working with the information, and that will help you retain it better than looking at an automatically generated diagram. Another way that we can look at the relationships between the packages is by creating a dependency matrix. So the dependency matrix, can you see this at the back? And it's not as important to know the exact packages, it's just to give you an idea of how you can use this. So here we see the same packages that we see in the project view. Because it's a matrix, obviously the rows and the columns are the same packages, but you might notice that they are sorted differently, and that's because the packages that are used by a lot of other packages are sorted towards the bottom, and the packages that use the other packages are sorted towards the bottom. I think I said something wrong just there. So anyway, the packages that are used are at the bottom, the packages that use them are at the top. And as we can see by the legend here, the blue boxes mean that there are dependencies between the packages. We can hover over them to get the information. So the package Cucumber Java uses the package Cucumber Core 209 times. And if we click it, we can also see the direction of the dependency. So the green dependency uses the yellow dependency. We can do that for different packages. We can click individual packages to see what it uses or what it's used by. So that will also help us get an idea of how they are related and maybe which ones we should look at first. So together that can help you create a mental model of how it works. So we've looked at project structure, we've looked at the README, we've looked at either automatically generated diagrams or drawing our own. We can also look at dependencies. So for Cucumber, for example, each package has a POM XML, so we can see what it uses. We can draw diagrams from that. And we want to build and run our project. Another reason I like to look at dependencies is because I like to know if I'm starting to work on a project, I like to know what libraries are used there, whether I know them already, or whether I might want to go read some documentation or at least figure out what a particular library is for. Strategies outside the IDEs are also to identify the components, but maybe on a larger scale. So how is this application, what's its place in the landscape? Identify relationships and dependencies, identify concepts we might want to know more about, and gain context of the why of the application. Why was it built? How does it work with other applications and teams? A next way to familiarize ourselves with an application is by looking at a particular slice, which can either be a particular slice of the application that is relevant to the task that we are doing at the moment, whether it be trying to understand this particular code base or trying to perform a certain task like fixing a bug or adding a feature. So first we need to find a starting point. If we're just trying to understand the code base, that might be more generic, like a main method or an endpoint. If we're working on a particular task, it might be more specific, like an error message or specific functionality. So here again, our IDE can help us. So we might look for the main method. Nope. Who's using Spring? You know that if you find the main method in Spring, that's where the Spring magic starts, so not maybe the most useful place to start. So we might look for a controller, which is an entry point to the application, and we might look from the controller at a specific endpoint and navigate to what happens next. So from the service layer or from the controller to maybe a service layer if there is one, not in this example, to the repository and back up again to get an idea of how this particular endpoint interacts with the application. Finally, we might start looking for example, we might want to figure out a bug or figure out where a particular log message is coming from, so we might look for an error message. We find where in the code this error message is logged, and then we can go back up again to how does the code get there. When we find the location where the error message is thrown, we can check where this class is in our particular code base. So we can have kind of like a you are here in the code base from the location that we found. So there are different ways that your IDE can help you search and navigate the code based on what you're looking for related to your particular task. So strategies here are to think about a particular use case. How would a user perform a particular task? What is relevant to the task that I'm currently doing? And again, to draw your own diagrams also related to the task that you're working Finally, we might find a piece of code that we really need to understand, maybe the location where we need to make our changes or fix a bug. This is where, again, structured exercises can really help. I don't know if you've ever found a piece of code where you honestly really have no idea what's going on, and you don't even know where to start. Yep, one of us. Anyway, so it's not just you. So if that happens, structured exercises can actually help because they can get you over that hump of, you know, freezing and not knowing what to do. Pick an exercise from Code Reading Club or from Felina's book. Any random exercise will do because it will give you something to do and a way to get started. And of course, your IDE can help. So, obviously, if we are writing code in the IDE, it will take care of the formatting for us. But we might encounter code that isn't properly formatted. So if we have code, one of the fun things about advocacy is you get to write code and then mess it up so you can use it as an example. Yay. Anyway, you know, or build a pipeline, break it, only to use that for something. So we can use our IDE to reformat our code, which will help us make sense of it. Sorry? Yes? No? Yeah? Thank you. So, yes, of course, being able to actually read it helps to be able to read it. So if we find code that isn't properly formatted, we can use the IDE to format it. I don't know if anyone's ever done any of the Oracle exams. Some of us, okay, because they really like to mess up the formatting to make it extra hard on you. So actually, if we're reading code, we're not reading it linearly from start to finish. We're actually more often scanning the code, looking for the sections that are interesting to what we're trying to do. There are several ways that the IDE can help you with that. For example, you can collapse all of the code so that you only see the method names and not all of the details to give you a quick overview of what a class is about. There are different ways to get that same overview. You can look at the file structure, which will give you an overview of the methods. You can use that for navigation as well. Or the structure tab, which has the same information, so to give you a quick overview of a particular class, for example. Yeah, so we also use white space, so that's why it helps to be consistent with white space when writing code, because it will help us scan and find the things that we want. And note that even if we have collapsed the code, we can still search the code, and the relevant sections will expand. So, for example, if I'm looking for payment information, where that is used in the code will expand. We can search for particular things. I can't type when people are watching, sorry. So if we search for something, it will be highlighted in the code, which will help give us that dependency graph of where variables might be used in the code, for example. We can, of course, move stuff up and down. And I know that I said, you know, we're reading for understanding, but sometimes sort of playing with the code and reshaping it a little bit can also help with your understanding. For example, we might refactor the code a little bit for our understanding to a style that we're more familiar with. If we're not so familiar with streams, we might prefer a for loop or the other way around. We might, as we are gaining understanding of the code, we might want to rename certain variables if we have a better name in mind, or just to help us, okay, this thing is actually, the item is actually an order item, an item in an order. We might want to extract methods and give them a meaningful name. to break up a long method into smaller parts with meaningful names that might help us understand what's going on. We can inline variables or not. That's the fun thing about refactoring. We can move it both ways. So we can kind of reshape the code into a style that is more familiar with for us, or rename things as we gain understanding. Of course, if we want to look at the behavior of the code, we might want to run tests and run them through the debugger. So we can navigate to the tests for a class and run a specific test through the debugger. We've placed a breakpoint in the code, so when the code hits the breakpoint, execution will stop. Who's familiar with using debuggers? Everyone. Okay, so quick highlight of debuggers. My colleague Anton Arhipov has a great talk on debuggers if you want to get more out of your debugger. You can find that on YouTube. But quickly, we can run through the code, step into a method if we want to see, or step into a line of code if we want to see how the methods called on that line are executed, or step over them if we don't. I also really like being able to evaluate expressions when the breakpoint is hit, so we can evaluate the value of a particular variable, and we can also change the thing that we're evaluating, so we can also get information on the state of things that isn't already shown in the debugger. But you're all using the debugger, so yay. Let me finally, we might want to look at the context of the code. So we might want to figure out why a particular line of code was changed, for example. So we can look at our Git history, for example, and from there we can go to the specific commit that this was a part of. And we can, of course, look at the changes that were made in the code to figure out what happened there. In my previous job, we had the habit of putting the issue in the commit message. So the issue in Jira or U-Track or whatever issue tracker you're using, so you can go there to get more context on why this particular change was made. So you can go over the changes that were made as part of a particular commit to get some context of what happened there. A feature that I really like is that you can also use AI Assistant to explain the commit to you. So instead of going over all of the files and looking at all of the changes, you can ask AI Assistant to tell you what happened in this particular commit, which can be really useful. Excuse me. So we can look at the structure, we can look at hints from our IDEs. I forgot to mention, but we all know we have syntax highlighting, we can pull up documentation and type information, we have inlay hints for type inference, we can refactor the code for our understanding, and we can get context from the Git history. Strategies outside of our IDE might be using structured exercises, using memory aids like dependency graphs and state tables, and gaining context of the landscape that the application is a part of. So what's next when you're armed with all of this information? If you're interested in doing structured exercises or joining a code reading club, I recommend going to the Code Reading Club website. They have a Discord as well that you can join if you're interested. And if you want to try this out at home or at work, they have resources on GitHub where they have, I think, 3 or 4 sessions all pre-planned for you with a sample of code and exercises that you can do with that code. So if you want to try it out with your team or some colleagues, like-minded colleagues, or software developer friends, all my friends are software developers pretty much. Or if you want to know more about how all of this works, or you want to try some individual exercises, you can also find many of them in Fellini's book, The Programmer's Brain. And of course, let your tools help you, because most of the time we'll be reading code in an IDE. Even if you're doing a code review, our IDE also has integration with GitHub and GitLab, so you can do the code reviews in your IDE, and then you have the context of the project and the syntax highlighting, etc., which is easier than the web UI for code reviews. Of course, use your brain, because that's our job. And if you'd like to have the slides and links to some of the stuff I've discussed and relevant other content, you can find it on my website. And I've already posted the slides from today there as well. Thank you. Or mulțumesc. If there are any questions, let me know. Ah, thanks, the Dutch guy. So what kind of so what kind of diagrams you have there is actually depends on the project. For example, in the Spring Pet Clinic, we can generate a Java classes diagram, so kind of like a UML diagram. We can see the project modules, which I've showed you in the Cucumber project. So this module uses these other modules. We can see the Spring model dependencies, and we can see the Gradle dependencies. Here, I already closed the Cucumber, but there you can have some different, so it depends on the context of your project, basically. And for this demo project, I can only generate a Java classes diagram. So IntelliJ IDEA will decide what kind of diagrams are relevant for your type of project. But do play with that, and there may or may not be a video coming on the YouTube channel. Like and subscribe. Thanks. Yeah. Yeah, so the question is, for a code review, what do you have a kind of strategy, where to start? Do you need to be familiar with the project? I explicitly did not include code review as one of the use cases or tasks that I discussed, because in code review you're more often judging the code more than trying to understand the code, although I would highly recommend to first start with understanding before you judge it, because often you'll see code and like, that's not how I would have written it. Okay, but that doesn't necessarily mean that this solution is wrong. And also that person might have been involved with the problem, considered multiple solutions and ended up with this one. Or they might just be like, why did you implement it this way? Because that's how I got it to work. So, yeah, I'm going to be really annoying and say it depends on, you know, if it's a project that you work on and you might be also responsible for maintaining this project in production and fixing any bugs that might arise from this change or other future changes. Again, it's going to be really important that you understand this code, because you will also be responsible for maintaining this code. So in the teams that I was on, often some of my comments might be, can you please explain what's going on here so that I know how to support this in the future? For me, everybody has their pet peeves or things that they care about in the code base. For me, one of those things is testing. So I might look at, you know, are there proper tests in place for this code that we will add so that we know it won't break in the future? Do those tests explain what the code should be doing so that if it breaks in the future, I don't just have to figure out what broke, but also what it's supposed to do. And it will help me get to the solution faster. I tend to care about consistency. So, you know, is the style of this code in line with the style of this code base? And if not, what is the reason? Because in the future I'm going to be looking at this code and I'm going to maybe wonder, why is this completely different than that? And it should be more than just this, it was implemented by someone completely different. If I have to figure out why it's inconsistent, that's going to cost me extra cycles of trying to understand the code. So yeah, all of those things might be relevant, but also why are you go back to the why are you doing the code review? Is it to make sure that no bugs slip by you? Is it to make sure that you can maintain this code? Is it to make sure that you know, your more junior programmer understands this code base and chose the best solution? So again, sorry, it depends. Thanks. Anyone else? Otherwise, I'll be around all day if you're not comfortable asking questions in a big room. What version of the IDE did I use? I'm hopefully using the latest or the latest -1. So I'm using 2023.3.6. I think 0.7 might be out, but this is the latest? Thanks. Ultimate, yeah. Or maybe the EAP is at 7. And I'm using AI Assistant, which is an additional service on top of IntelliJ IDEA, which I get through work. Hopefully you can too. Anyway, if you want to try it out, there is a free trial that you can use with Ultimate. Sorry? Just a little bit. So the question is, I saw you worked on the Cucumber project. I did, but only a little bit. So only on, how hard was it? But I'll be honest and say that I've only worked on like limited parts of the code. So none of the changes that I've personally worked on touch all of the packages. And the core, yeah, it's pretty much like if you're new to a code base or new to a team or a more junior programmer, you might work on tasks that are smaller or more limited in scope, so that you can, you know, have an understanding of and a mental model of what you're working on. And as your experience with the code base grows, you might work on larger, and your experience in general, you might work on larger changes. So in my case, I've worked mostly on stuff that was limited in scope, where the core maintainer would tell me, okay, yeah, it's roughly there. You need to look at this and that. And of course, if you're a more senior programmer, you can help your juniors by, you know, giving them kind of a roadmap. And then gradually letting them go and wander off into the world. There was another question. Is any of the diagramming also working in the other IDEs like Golang or Rider? Yes, most of the IntelliJ features I've showed you should also be available in our other IDEs, with one exception I know of. The dependency diagram, the dependency matrix that I showed you, is only available in IntelliJ, unfortunately. Okay, thank you all so much also for the great questions. See you around.